Hey everyone, and welcome back. Are you ready for another deep dive?
Absolutely. I'm excited to see where we end up today.
Today, we're going to be taking a look at a recent discovery by NASA's James Webb Space Telescope.
Always an exciting place to start.
It has to do with planet formation. It seems they've discovered a planet-forming disk much older than scientists thought possible.
Oh, wow.
Yeah, and this discovery could have some pretty big implications for how we understand planets and, maybe even life beyond Earth.
I'm intrigued. Let's hear more about this.
Okay, so to kick things off, can you remind us what exactly are these planet-forming disks?
Well, imagine a young star surrounded by a swirling cloud of gas and dust.
Okay, I'm picturing it.
That's a protoplanetary disk. It's basically the birthplace of planets.
Ah, okay.
Yeah, so over millions of years, all that gas and dust clumps together and forms the planets that we see today.
So if I remember correctly, these disks were thought to disappear pretty quickly, right? Like within about 10 million years?
Yeah, that's right. Scientists used to believe that these disks had a relatively short lifespan, which, didn't leave much time for planets to form.
That makes sense.
But this new discovery is really turning that idea on its head. This new disk they found, it's orbiting a star called J0446b.
J0446b.
Yeah, catchy name, right?
Well, I'll try to remember that.
And get this, it's estimated to be a whopping 30 million years old.
Whoa, that's 3 times older than what was thought possible.
Exactly. It's a cosmic senior citizen.
That's incredible. So where is this J0446b located?
It's about 267 light years away from us.
Okay, so pretty far out there.
Yeah, it's in the constellation Columba.
Columba, got it. And what kind of star is it? Is it like our sun?
Actually, it's much smaller. J0446b is what's called a very low mass star.
Okay.
It's only about 1/10 the mass of our sun. But despite its small size, it still managed to hold on to this ancient protoplanetary disk.
That's fascinating. So what does this tell us about how planets form around stars like J0446b?
Well, it suggests that the process might be a lot slower than we initially thought.
Okay.
Instead of a rushed 10 million years, these planets have a leisurely 30 million years to grow and evolve.
So more time to bake, so to speak.
Exactly.
Oh.
And that means they could develop in ways that we haven't even considered before. There's also another interesting aspect of this discovery.
Oh.
The researchers found that the chemical composition of J0446b's disk doesn't change much, even after all these millions of years.
Wow, so it's a very stable environment.
Yes, very stable. And that kind of stability could be incredibly important for the formation of planets. It provides a consistent supply of the building blocks they need to grow and develop.
I see. So it's not just about having more time, but also having the right conditions over a long period.
Exactly. And it's important to note that they were very careful to make sure that this wasn't what's called a debris disk.
Right, because debris disks are different. They're made up of leftover material after planets have already formed.
Yeah.
So they needed to be certain that this was a true protoplanetary disk.
Yes, they needed to confirm that it was still churning out the ingredients for planets.
And how did they do that?
They looked for signs of what's called primordial gas.
Okay.
This is the gas that was around in the early universe, and it's what protoplanetary disks are made of.
So if they found primordial gas, that would mean...
That would mean this disk is truly ancient. And guess what? They found it. They detected hydrogen and neon, which are clear indicators of this primordial gas.
Wow, so this is a really big deal, right? I mean, this discovery has huge implications for other star systems too, doesn't it? Especially ones like TRAPPIST-1.
Ah, yes, TRAPPIST-1. Now, this is where things get really interesting. Because TRAPPIST-1 is also a red dwarf star, much like J0446b.
And if you remember, it's home to 7 Earth-sized planets.
Yes, and 3 of those planets are in what's called the habitable zone.
That's the sweet spot where conditions might be just right for liquid water to exist on the surface, right? So now, think about what we've learned about J0446b and its long-lived disk.
Oh, I see where you're going with this. If TRAPPIST-1 also had a disk that stuck around for tens of millions of years,
it means those planets had a lot more time to evolve, to potentially develop life.
It's a mind-blowing possibility.
I'm starting to understand why everyone in the astronomy world is so excited about this discovery. It really challenges our understanding of how planets form, especially around these low-mass stars.
And remember, low-mass stars are incredibly common. They're the most abundant type of star in the universe.
So this isn't just a fluke, a one-off event. This could be the norm. we might have been looking in the wrong places all along when searching for signs of life.
It's definitely a possibility worth considering. This discovery has really opened up a whole new realm of possibilities.
This is incredible, but it raises another question. If these long-lived disks are so common around these types of stars, why haven't we seen more of them before now?
Well, that has to do with the limitations of our previous telescopes.
Right.
They just weren't sensitive enough to detect these faint disks around distant stars. But now, with James Webb, everything has changed.
It's incredible what we can see with James Webb, isn't it?
It really is. It's like having a brand new window into the universe.
I feel like we've only just scratched the surface of what this discovery could mean.
Oh, absolutely. We've got a lot more to uncover. But I think it's time we take a little break. We'll be right back to delve even deeper into this fascinating topic.
Welcome back, everyone. All right, so we've got these long-lived disks. They're full of planet-forming material, and they're hanging around way longer than anyone expected.
Right.
What does this mean for the kinds of planets that might form? I mean, could we see planets completely different from anything we've ever seen before?
Well, yeah, that's what's so exciting about all this. I mean, think about it. If you have a much longer formation time, it gives planets more time to try out, different combinations of elements, different structures.
So instead of rushing to form within a few million years, these planets have the luxury of really taking their time to develop.
Exactly. They can slowly evolve and maybe develop their own unique characteristics.
So it's almost like planetary evolution on a whole other time scale?
Yeah, you could say that.
Yeah.
And it could lead to some pretty wild planets with compositions and atmospheres that we can't even imagine.
Okay, so we've talked about what this means for planets, but what about life? I mean, could these long-lived disks actually increase the odds of finding life beyond Earth?
Well, it's certainly possible. I mean, for one, that longer formation time.
Right.
It gives planets more time to develop more complex environments,
Uh-huh.
And don't forget, we were talking earlier about how the chemical composition of these disks seems to remain pretty stable over millions of years.
Right.
And that kind of stability, it could be really crucial for the emergence of life. You need things to be somewhat predictable for life to get a foothold.
So these long-lived disks, they're almost like a perfect cradle for life to arise and evolve.
It's kind of a beautiful thought, isn't it?
Yeah.
And if you consider that these low-mass stars,
Yeah.
the ones that seem to have these long-lived disks,
Yeah.
they're the most common type of star in the universe.
Wait, are you saying that the most common type of star in the universe might also be the most likely to host life?
Well, it's a possibility, isn't it? I mean, we need to do a lot more research, obviously, but it's one of the many reasons why astronomers are so excited about studying these long-lived protoplanetary disks.
I mean, it completely changes our perspective on where to look for life, doesn't it?
It really does.
But, it also makes me wonder, what about our own solar system? I mean, are we just a fluke, like a rushed job compared to these slow-burning planet factories?
Well, it's possible that our solar system is just one example out of countless others, and each one has its own unique history.
Yeah, that makes sense.
But by studying these other systems, we can gain a better understanding of the processes that led to the formation of our own planet and the conditions that allowed life to arise here on Earth.
Oh, okay. So studying these alien worlds can actually teach us more about our own home.
Absolutely. The more we learn about our cosmic family, the more we understand our place within it.
Wow. It's incredible to think about, and I feel like we've barely scratched the surface of this topic.
I know, right? There's so much more to explore, but I think it's time we take a little break and let everyone digest all this amazing information. We'll be right back to wrap things up.
Welcome back, everyone. I gotta say, I'm still kind of mind blown by this whole idea of these long-lived planet factories out there.
Yeah, it really does make you rethink things, doesn't it? We're starting to realize that maybe things happen a lot more slowly than we thought.
Yeah, especially around those low-mass stars.
Right, exactly.
It's like the universe is saying, hey, slow down. Good things take time.
Yeah, I like that. And it could mean big things for, finding other planets and maybe even life out there.
More time for those planets to develop, right? More time for life to, I don't know, get started.
Yeah, exactly. More time for things to evolve.
And it makes you think, what do we even consider a habitable world, right?
Oh, yeah, that's a good point.
If planets have more time to evolve, maybe they develop these really weird and unique environments that we haven't even thought of.
For sure. I mean, we always get stuck thinking about like liquid water and stuff.
Right.
But what if there's life out there that doesn't need any of that?
I know, it's crazy. Like, what if there's some kind of, like, giant gas planet with floating jellyfish creatures?
Or like an icy moon with a whole ocean underneath full of, like, glowing creatures.
Who knows?
It's exciting to think about. And that's what I love about this kind of research. It's not just about answering questions. It's about opening up whole new questions.
So where do we go from here? What's next for, figuring out more about these planet factories?
Well, I think it shows us that we got to keep looking at these low-mass stars.
Yeah.
They hold a lot of secrets, about how planets form, about the universe. And with telescopes like James Webb, I think we're only going to find more cool stuff.
Speaking of James Webb, could we even have found this ancient disk without it?
I don't think so, no.
Mm.
I mean, James Webb is so sensitive, It can see that faint infrared light from these disks. Older telescopes, no way.
It's amazing what we can do now, isn't it?
Yeah, it is. It really shows what humans can achieve when we put our minds to it.
Absolutely. Well, this has been amazing, but before we go, I want to leave everyone with a little something to think about.
Oh,
If these planets around low-mass stars have so much time to evolve, what does that mean for life? Could there be, like, civilizations out there way older than us just watching us?
That's a great question. Something to ponder for sure.
I know, right? Makes you think. Well, thanks for joining us on this deep dive, everyone. It's been a wild ride. We'll see you next time for another exploration of, well, everything.